Alright, so another example here of evaluating a trig function for an angle in the plane. And again, so here's our definitions of sine, cosine, tangent, cosecant, secant, and cotangent. And again, the idea in this problem, what we're going to do is we're going to be given a point on our angle, and we're going to use that to deduce the values of some of the trig functions for that angle. So we're going to find the values of sine theta and cosine theta for the angle theta in the standard position on the coordinate plane with a point 7, -2 on the terminal side. So again, so we go over 7 units on the x-axis, down 2 units on the y-axis. So here's our point 7, -2. Our angle again, there's our angle theta. But again, all we have to do to figure out sine of theta and cosine of theta, remember we said sine of theta is simply the value of the y-coordinate over the r value, which you can think about as being sort of the radius or the distance from the origin. And cosine of theta is defined to be the x-coordinate over that r value. Alright, so let's see. So sine of theta is the y value over the r value. Cosine of theta is going to be the x value over the r value. Well, for sine, we already know the y-coordinate. We've gone down. The y-coordinate is going to equal -2. Still don't know the r value yet. Likewise for cosine of theta, though, we know the x-coordinate. We've gone over 7 units. But we still don't know our r value. But to figure out the r value, all we have to do is just simply use Pythagorean theorem. So let's see here. So if we do Pythagorean theorem, we can think, well, we would have 7 squared plus, okay, I know we've gone down -2. When you think about maybe Pythagorean theorem, you're thinking about lengths of triangles, but it's all going to work out the same since you're squaring it anyway. So I'm going to plug in -2 squared. That's going to be our r value, so that'll equal r squared. Well, let's see. 7 squared is going to be 49. 2 squared is going to be 4. That's going to equal r squared. 49 plus 4 is going to give us 53 equals r squared. And now we could simply take the square root of 53. Again, normally we get positive and negative, but again here r is always going to be a positive number. So likewise, 53 is a prime number. It doesn't really factor at all except for, 1 and 53. So we can't break down our r value at all. We can't reduce this radical. But again, so now all we have to do is just plug that in. So sine of theta, we said that's y, which was -2 over r, which we just found to be the square root of 53. Cosine of theta is going to be the x-coordinate, which is 7 over the square root of 53. And again, if you want to, sometimes people don't like to see radicals in the denominator, so you could rationalize by multiplying numerator and denominator by the square root of 53. In the numerator, we would have -2 square root of 53 left over. The square root of 53 times the square root of 53, those just kind of cancel out and give you 53. Likewise, if you multiply top and bottom by the square root of 53, we'll just get 7 times the square root of 53 over 53. And that would be my answer for cosine theta, and the first one would be my answer for sine theta.